So what we did yesterday's session, we had gone through the arrays. We understood about what arrays are, and we also had gone through, you know, I hope I'm audible. We also gone through what kind of arrays we have: two-dimensional arrays, three-dimensional arrays, and any dimensional arrays. In fact, we can create every dimension we add. If you want to iterate through the array, we need one more loop. So we also had gone through how to use the range loop on this arrays and stuff like that. After that, we started with the slices. We started with slice. So slice is kind of as I said earlier, uh, you can talk about a slice. Slice is an extendable array. Slice is not an array. Slice itself is a data structure, but it's like an array, but it can be extended actually. It can be extended. You can increase the size. You can add new elements to the slice at runtime. That's what we discussed. And we also started discussing about the slice header. So whenever we are working with slice, it's very, very imperative to understand the slice header. Understanding the slice header is very, very important in Golang. That's where actually even we ran this. We have printed this slice header. Okay, percentage P, D, D, and all these things. We have printed all these things because the slice header. So slice is very, very important in Go language. Okay. We seldom use arrays in Go. Most of the cases we use only slices. The reason we use slices is because arrays are fixed length, and then it is not going to suffice all the use cases that we're gonna do. And second thing is when you write methods on functions or methods on arrays, it's very, very difficult because you cannot keep on writing different methods for different slices, which is very, very difficult. So what we do, we always go for uh, slices in most of the cases. Majority of the cases, we don't use arrays. In majority of the cases, we use slices. Fine. Uh, Coming to the slice header, slice contains a header. That means whenever you create a slice, it creates a data structure, which we call it as a header internally. This is very important to know. Based on this only, many things we will come to know. Fine. So this is the header. Address of the slice header, length of the slice, capacity of the slice, and the pointer of the slice. Pointer talks about the first element of the particular slice. This is where we get address of the slice header. This is the address of the slice header. Remember that means the actual structure, the structure of the slice. The length is 5, capacity is 5, and the pointer is this. This is the actual memory where slice started, allocating memory to store its elements. We are doing it slice 1, you know. Uh, Similarly, there is slice 2 and slice 3, etc. Okay, and this is what we discussed. So now what we do is we copy stub to 18 slices. This got to be a stub. So I got to go here. Now, most of the scenarios, we create slice like this. Slice 1 colon equal to make of what kind of a slice it is, integer slice. How many elements, what is the length, and what is the capacity. We already saw that this is how you declare slice in majority of the cases. If you declare a slice like this is a nil slice. The reason it is a nil slice, the reason is very, very important. it is a nil slice. The reason is pretty straightforward, that this slice has been declared but not instantiated. It has not been instantiated. The slice has not been instantiated. It's just a declared but not been instantiated. Okay. This is what the slice header perspective. Slice header is created. Whatever slice header is created, I create a function. Print slice header is a function. This function is going and then printing the header of the slice. I pass a slice as an input parameter. Okay. You can also have. I'm not returning anything as such for this function, but I'm going to print the slice header. So I also would like to give the slice name, just to know that which slice we are printing. Name of the slice. So print line slice name. Okay, print line slice name. I printed slice name. After this, fmt dot uh, s fmt dot sprintf. Okay, fmt dot sprintf. fmt dot sprintf. Uh, you know, here what? Sorry, not print sprintf. It's a printf. What we're gonna print? Address of slice header. Percentage p is gonna print the address. Okay, and then we can have the length percentage d and capacity, which is also percentage d. Slice, slice, and then slice. This is gonna print the slice header. That means the address of this header. That means what happened? Print slice header of slice one, slice one. Similarly, I have print slice header of slice two, of slice two. So this is the sorry, and length is length of slice, and the capacity is capacity of slice. Here also it is the address of slice. Just to say that print line here I got 50 new line. So this is slice one header, address of the slice headers. Remember that this is the address of the slice header, not the actual data. So how can you print the actual data? You can print only actual data if the slice has some elements. Here slice has some elements, but here there are no elements in the slice. So what I do, if slice not equal to nil, that means if the slice is not nil, fmt dot printf pointer is percentage p, which is address of slice of 0. You're gonna print the 0th element of the slice. It prints only if the slice is instantiated. This is the This is the pointer. You see the difference. This is the pointer of the slice header, and this is the actual pointer of the slice. There is some difference between here. It has not printed because we are checking whether it is nil or not. That means here the slice is not nil. If the slice is not nil, then only we are printing. If the slice is nil, we are not printing the actual pointer. And you can see the length and capacity as well. Length is given and also the capacity is given of the slice. Fine. Now, I want to add new elements to the slice. There are two things. If the slice is nil, whether slice is nil or not, we can append elements to the slice. One thing, append is a built-in function. Add new elements to the slice. Append is a function that is used to append new elements to the slice. Append is a built-in function. Append appends to the end of the slice and return the slice. What append does? Append appends to the end of the slice and return the slice. That's what we want to do. That's what it does. I also write a function fill slice with random numbers. Fill slice with random numbers. What I do, if slice not equal to nil, then only we can fill it with random numbers. That means for index comma value, range of slice of I, we don't need value basically. Slice of I equal to v2 dot int n of maybe length of slice 10. What does it mean? The range, how many numbers? Length of slice into 10. Length of slice maybe into 10 or plus 10. Length of slice into 10. Length of slice plus 1 into 10. Otherwise, the problem is, what if it is 0? Yeah, fine. Just range. This is the range of random numbers. Nothing I'm doing. Just adding to the range of random numbers. And I return the slice. Remember that I return the slice. It is telling that it's an unnecessary check on the range. Whenever you are using the range loop, there is no need of actually check. Fine. Fill slice with random numbers. So what I do here is I have created a slice here. So I fill the slice with the random numbers. And again, I print the slice. See, first print the slice, fill the slice with random numbers. This is the header of the slice. This length. This is capacity. Let's also print the elements of the slice. Right. Okay. Print the elements of the slice. What I do, if it is not nil, I also definitely dot print line slice, printing the elements of the slice. So slice one, address of the slice, length of the slice, capacity of the slice. This is the actual elements that slice are. That means this is the address of the zeroth element. This is the address of the zeroth element, and all. So the slice is filled with new numbers. You can see that the pointer is same, but the header is different. The reason the header is different is we are returning the slice. For example, in case I don't return the slice, I just pass the slice, I don't return the slice. So this is the header of the slice. This got to be the header of the slice. The address is same. This is same because we are using the same slice. We are using the same slice. But what we are doing here is actually we are passing the slice to a function. We are passing the slice to a function. For example, I do the same thing here. Okay. There is a catch actually. You will understand actually a little bit later on. Right now you may not be able to understand, but sure you will understand it later.
But when you print the slice one, the header is different, right? Only pointer is same or header should be same or not?
So, I say that print slice header. Okay, what am I printing is very important actually. If you really look at it, when I say print slice header, it's a pretty tricky part. Plain print slice header. Whenever I'm calling a function called print slice header. Remember that I'm calling a function. Okay, it's called print slice header. Functions are two types. I mean, the arguments to the functions we can pass it in two types. Generally, they are called by reference and then called by value. Pass by reference and then pass by value. This is pass by value. We will see that how is pass by reference, but this is pass by value. So what happened? The slice is going inside the function and this entire slice is copied over here. You see that two times I call, for example, line number 13 and line number 18. The header has been, this is the address of the header, and here this is the address of the header. Why the address of the header gets changed? The reason is slice is passed as an argument to the function. We will discuss more about pointers in the next concept. You will have clarity on that, even more clarity, but right now it's a pass by value. The values are passed to the function. So whenever you say print the address of the slice, it is printing the passed address. It is printing the local copy address. Header address means it's printing the local copy address of the print slice header. For example, instead of this print slice header, if I see the header is copied, number one, the header is copied. What is the meaning of header is copied? All the data inside the header gets copied. What all data header contains? Header contains the pointer, header contains the length, header contains the capacity. Header is copied, but it creates a new variable to that particular price slice to the function. So whatever I'm doing here, print slice name, let's say I copy this. Okay, instead of this, I print this. Let me put it as slice one. So slice one, slice one, slice one, slice one, slice one, slice one. Similarly, I fill the slice and then I say again slice one and then I say slice two. Slice two got to be slice two, slice two, slice two. So what happened here exactly is I'm commenting the code over here. Okay, I'm commenting this as well because I'm passing directly. Right. Now, first I have got a slice. I instantiated the slice with some memory. How do I know that there is some memory? Because we are using a make function. Make function is going to build the slice with the 10 elements. Okay. Make function is going to build the slice with the 10 elements. That means the length is 10 and the capacity is 10. I'm declaring a slice at line number 12, which is going to declare a new slice, but it is nil. What do I mean by nil? The mean by nil is not the header is nil, but the meaning of nil is the pointer inside the slice is nil. That's why pointer, the nil is very curious case in Go language. That's what I always say, that nil in Go language is quite curious case. It's not the straight away approach. Fine. Coming to the slice one, I am printing the slice. I am filling the slice. I am again after filling, I am printing the slice. Header means all the details about the slice, and then again slice 2 header. Nothing to do with slice 2 right now. We are not doing anything, but still it's fine. So you can clearly see that when I am not passing to the function, the slice header is same. The header pointer, I'm not telling the header is not only the header is same, but even the header pointer. This is same. Header pointer is same even after I fill. The reason is it's you're not passing it, you're not passing to a function, so that function always copies a new copy of the slice, new copy of a variable, as unless it is a pointer. Unless it is a pointer, function copies a new copy of a variable. So the slice header is this, the slice header is this is the length, this is the capacity, and this is the pointer, and these are the values. After filling it, these are the values. Fine. Well, this slice is nil, so nothing to be printed with respect to the values. Fine. I'm going back. I just would like to uh, for you to understand what is happening over here. Okay. I just remove it. Fine. I Fine. Now I would like to ask you a few questions. Okay. Question number one. What is slice header? Of string. Once again, just going back to the concept of string for you to understand even the slices. There is a concept we always think that string is immutable. The meaning of immutability here is very subjective. Let's say I have a string and then I say str1 equal to hello universe, for example. So the question that arises here is, I have declared a string, I have created a string or created a string variable, and with a value, I reassign the value, another value to the string. So this is called as mutability. So how can you say that string is immutable? So the concept is same. Whatever we have been discussing so far, the concept remains same. There is a string. String contains string header. This header contains the pointer and the length. What this pointer contains? It points to actual data. And this is the length of the actual data. It's a string is what actually is an array of bytes. So this string is a data structure which contains two fields. One of the fields is pointer, and the other other field is called the length. Two fields. String contains two fields. That's what actually we were talking about the string header. Fine. That is also fine. Now, what about the mutability part of it? Actually, string is immutable means even uh, uh, when you reassign the data to string, okay, it reallocates the memory elsewhere. The memory gets reallocated elsewhere. For example, if you really would like to see this print line, I want to print the fmt dot as print, oh sorry, printf printf pointer of the string ptr of the str1 percent is p. How can you get the pointer of a string is actually you need to convert the string to a byte array. The reason is string is nothing but collection of bytes, and you need to get the zero address of that zeroth element. You cannot directly get the pointer of the string, but you need to get the address of that particular zeroth element. That's what actually whenever you try to get the address of the string. Okay, I'll tell you. We will understand more about it in pointers concept, but just would like to explain this concept over here. So printf two prints we are doing. So you see that the zeroth byte address of the string is this. After I mutate the string, the zeroth element address got changed. What does it mean? That means that string is reinstantiated, and the pointer inside the string header is got updated with a new address. See that here, both of them I am printing the address of the zeroth byte. Now that means index starts from 0, so I am printing the address of the zeroth byte. So whenever I am printing the address of the zeroth byte, it could it clearly gives that indication that okay, this is what we talk about immutability. Immutability. Immutability means the string is not assigned to the same address, rather the string is given to the different address. That's what exactly the immutability with respect to the string and all.
So in this case, the header will be same in both the
Yes,
print cases.
exactly, exactly, exactly. The header is same. That's excellent thing. The header is same. The header is same, but what gets changed is the let's say pointer to the string and then address of str percentage p. I also get to give address of str percentage p. what I do, address of str1, and also I put the address of str1. So the address of the header is same. This is the address of the header. Address of the class means you don't get the address of the fields inside the class. Generally, we don't get the address in Java and all, but in general, I'm speaking about this. The address of the str remains same, but inside that there is a field called pointer that gets changed. So string is same thing, exactly same thing happens even to the slices. Exactly same thing happens even to the slices. So you have to have the clarity about the address of string akin to the address of the data inside the string. Both of them are two different things. Address of the string is entirely different than the address, the data inside the string. That's a uh, that's what about actually the way how strings work, and the same way even the slices
How
work.
when we reassign, it is hello universe. So is there a way to print hello world or
Can you please?
after reassigning? After reassigning,
You cannot access directly because it gets into the garbage collector radar. Then garbage collector takes care of their deallocating the memory. You cannot go and then allocate it. Okay, fine. Coming to the slices. So once you reassign a value, of course you reassign a value to a variable, you cannot get the old value. That is fine. Now, now what I do is I say str2 equal to str1. What do I mean by I have created a new string. I have created a new string from the existing string. You see that str2 equal to str1. Then if you print the address of and the other things of str2, so this is the actual memory of the str1. This is the address of the header. This is the address of the, sorry, this is the address in the pointer inside the string. This is pointer inside the string, and then this is a pointer inside the string. Every time you reassign a string, every time a new string is reassigned from an existing string, it allocates full, it allocates memory. As simple as the string is, every time you assign, so you see that whenever it got assigned, so a new pointer to the header is created, of course new variable is created, and then new value is assigned, new string is assigned. That's very important thing with respect to the strings. But when it comes to the slices, the concept is little different. Headers and then pointer, all the concepts are same, but it with respect to slices, the other things are different. There are certain other things that are different. The other things, what do I mean by other things? When you copy a slice from an existing slide, the header gets copied. That we will see. That we will see. Uh, I think in the next session. But we go here where, okay, now now. So slice one. I fill elements to slice one. I printed element. I printed slice one after that. Now I would like to increase the slice. So what I do is slice 1 equal to append of slice 1 to a new value called, for example, 9999. This is a function 2. append an existing slice. Append is got to be a function. I have appended the slice to 9999. That means the slice has got the capacity, length is 10, capacity is 10. I'm going to add a new element to the slice. This is what I have done. Now I print the slice. Let me park this particular part aside. So what we did, created a slice, printed the slice, fill the elements in the slice, printed the slice, append the slice. Append is a built-in function. You have to append the slice and return a slice with 9991 and then print the slice header. This gets, the header gets printed. Then you see what exactly happens. So this got to be the header. Forget about this particular pointer as of now. Focus on only the internal structure. 1010 and this is the address, 1010 and the same address, but here the address got changed. The reason is the slice got extended. The length is 10, the capacity is 10, but it is going beyond the capacity. So what happens whenever, in most of the algorithms, whenever it goes beyond the capacity, the capacity gets doubled. That is very common for uh, any algorithm that you work with. These kind of algorithms, all the algorithms work in the same fashion. Okay, when it goes beyond the capacity, what happened? That capacity gets doubled. That's what exactly happened. Okay, that's what exactly happened. The capacity got doubled, and uh, since the capacity got doubled, it goes beyond the capacity. It cannot allocate, so it reallocated the slice. The slice got reallocated. Okay, that's how it happens. Let's say that if the capacity is 20 here, now the concept is different. You carefully observe here. This address got changed because it's going beyond capacity. So this 050, this is 66, whatever. But since it is not going beyond the capacity, when you append a new element from 10, the length becomes 11, then it is within the same pointer. So it got added over here. Since the capacity, within the capacity, it has not reallocated the slice. Okay, that is how that's how things work. So that's all for today. Actually, I have got some. That's all for today.